Okay, welcome. We're just about to do our next session, the final session just before the lunch break as well too. For those who are new to this room, I'm Shane McAllister. I'm a developer advocate with MongoDB, and I'm here in this room for the day for all the speakers. And next up, we've got a super interesting partner session. Migrating and building in the cloud requires enterprises to rethink their data infrastructure. If you're moving from on-premise to cloud or you were born in the cloud, businesses are looking to unlock real-time customer experiences and intelligence for their back-end operations. So, to lead this session, we have Joseph Moraes, who serves as a staff cloud partner solutions architect with Confluent and a Confluent Cloud evangelist. So I'm very much looking forward to this. So I would like you all to join hands to welcome Joseph Moraes to the stage. Thank you.
Can you help me find that? Oh, you found it. Didn't even realize I had to switch. So, hello everyone. Thank you so much for joining us today. Connecting at our session, connecting distributed data to Mongo and Confluent. So let me give you a little background about myself. Joseph Moraes, Staff Cloud Partner Solutions Architect at Confluent. So most of my career, 20 years plus, I know you can't believe it. I have been in industry as an architect or an operator. I used to run Mongo back at Urban Outfitters. 3 years ago, I got the opportunity to work for AWS as a technical account manager. Hope everyone loves their TAMs. And then I got this role here at Confluent where I owned the technical relationship with some of our biggest strategic cloud partners. So I'm absolutely thrilled you're here with us today. So as data and devices continue to proliferate, there is a vast opportunity for businesses to tap into their data to make their applications more intelligent. We enable companies to innovate with data more efficiently in real time through our offerings. It is evident from industry reports that getting data to the cloud is the future of any enterprise, and databases continue to grow even in this new world of cloud computing. I got to take a second, this isn't part of the presentation, but zettabytes, right? I am old enough, again, I'm dating myself, when I remember that the world's data set could fit on a terabyte or even a petabyte, and now we're talking about zettabytes. It seems like something from Star Trek. So let's quickly go through an overview of Confluent. Confluent delivers an enterprise-ready event streaming platform that becomes the central nervous system of an organization. At the foundation of our platform is Apache Kafka. Kafka has become the de facto infrastructure for connecting, processing, and reacting to data in motion from across any organization. Confluent has developed additional technologies to make Kafka cloud native, a complete set of tools and services for easy stream processing and a self-managed offering that can be deployed anywhere to run your applications consistently. So to give you guys a little background about Confluent, Confluent was founded by former LinkedIn engineers. So our founders built Kafka at LinkedIn when they had to deal with the challenges of dealing with event streams, but what they were working with was message queues. And the problem that message queues have is they lack persistence. So they had to do what a lot of tech startups did, and they invented Kafka. So they convinced their leadership to open source it through the Apache Software Foundation. And the first iteration of Confluent was just training people on how to use Apache Kafka at scale. Since then, we've grown quite a bit. We've gone through IPOs, and we have both self-managed offering, which I talked about, and cloud offering, and we're going to dive into those details throughout the presentation. So I'd like to highlight some critical features of Confluent which can accelerate distributed data connectivity. You could build streaming applications, connect and integrate hundreds of SaaS and legacy data sources quickly, and accelerate your application development. Data infrastructure is being reimagined to seamlessly harness data flows across all of your applications, databases, SaaS layers, and cloud systems. It's an entirely new paradigm that is purpose-built for the digital economy and the expectation of data in real time. Here, data is not static or passive. Instead, data is in motion. Most companies are completely rethinking their data architecture, and like Citibank, who said we need to shift our thinking from everything at rest to everything in motion. So for anyone here that is familiar with Apache Kafka, you've probably heard of event streaming, and we used to talk about this a lot. And you might be saying, Joseph, is data in motion just a marketing term? Well, tiny bit, right? The reality, though, is event streaming and what we think of event streaming, I think, changed quite a bit after the onset of COVID, right? Taking events and streaming them to a live audience kind of became what people think of, at least default. So this ambiguity was part of it. But the other part of it is to talk to technologists like yourself. So I think everyone in this room is acutely aware of data at rest, right? You've heard about that many times. So we're talking about storing an object to something like S3 or inserting a record into your collection of MongoDB. And we wanted to flip that concept on its head, right? Instead of waiting for data to land somewhere and then doing something with it, why don't we action on it as it ingresses our system? That's what data in motion is about. So as you may already be hitting the wall of database expansion, legacy data storage, like relational databases and mainframes, were not created for today's requirements. And consequently, providers of these systems tried to bolt on to features to compensate for the lack of capabilities. But this strategy cannot compete with data management systems that were designed and purpose-built to solve today's problems. I'm sure many of you have resources that are time or resource intensive. They lack agility. The data is locked into silos and they provide poor data accessibility, limited data support. They tend to be cloud blockers and most of all come with high cost. Today, we are looking for systems that are flexible enough to support multi-structured schemas and scale out to accommodate the world's largest use cases. As discussed earlier, Confluent can span wherever your data exists, providing you the freedom to leverage a fully managed service on leading public clouds and a self-managed service that you can deploy for workloads that remain on-premise, whether on bare metal, virtual machines, or Kubernetes. Confluent and MongoDB simplify and accelerate migration by connecting distributed data and staying synchronized in real time. So I think a lot of times when people think of their journey to the cloud, right, we're all doing that to some extent. The first thought, why don't we lift and shift our VMs to EC2, right? And I'm picking on AWS because I know it the best. The problem with that is you're just lifting and shifting your tech debt, right? But instead, you can do things, and we'll show this in our demo later today, you can do things like connecting all of your legacy data systems, replicating them into something like Confluent Cloud, and then syncing them into MongoDB. In this world, you can now build out all that new wonderful architecture, break down your monoliths, create your serverless architecture with a twin of your production data. So now, when it comes time to lift and shift, you just have to really point your data at the cloud as opposed to re-architecting everything. You've already done that. And because our replication technologies are bidirectional, failing back, I want to say simple, it's not simple, easier than normal. So, as many of us know, connecting existing data sources and syncs to our platforms is crucial for enhancing our real-time use cases with a broader set of data. In the past, you could build these type of integrations in a bespoke manner, but these can be expensive, brittle, and time-consuming. So let's talk about open source Kafka for just a bit. So in general, what everyone really knows about Kafka is you can produce and you consume messages to it. But there is also another open source API called Connect. Now, Connect allows us to either take things that are not Kafka, like mainframes, databases, and pull those in as Kafka events. We call those source connectors. We also can take Kafka events and we can sync them into other data destinations. We call those sync connectors. Now, if you're working with open source Apache Kafka and you want to connect things to it, you have basically two choices. One, you could develop your own connectors using the Connect framework. Now, the challenge with that is the time it takes. So back in 2019, we expanded our connector portfolio from around 10 to 100 connectors. And we measured in that time, it takes anywhere from 6 weeks to 6 months with a full-time engineer doing nothing but building that connector. And this is the time it took the world's Kafka experts. The other limitation with working with open source connectors, and there are a handful of really good connectors out there that are very popular, but they're unsupported, right? And I love the open source community. I helped build this company, but open source community does not come with an SLA. So if you're trying to build Connect and make that part of your production infrastructure, would you feel comfortable not having help with from the world's experts? So with that said, that's why Confluent offers a portfolio of over 120 connectors, around 90 of which are developed directly by us, and then about 30 or so are developed and supported by our partners like MongoDB and fully validated by Confluent. So let's take an example of change data capture, or CDC for short. Confluent's connector portfolio offers several CDC connectors to stream data to cloud-based data systems like MongoDB Atlas and Snowflake. CDC connectors capture changes in the database, including inserts, updates, deletes, making them bulletproof to data loss. They are critical to database modernization by allowing these source systems to be operational through migration, which is what we talked through before, right? We can incorporate our legacy systems, still build new things without actually having to migrate them right away, right? Because our plan to get off our mainframe may be a completely different team, right? We're the data team, we want the data from it, but the operations team has a 5-year plan to get off that mainframe, right? Do we want to wait 5 years to get the new data? No, we don't. So connectors, you could do that, and then once that mainframe's cut over, you just repoint your source connector, whatever the new thing is, and your data's still there. So, as one of the most popular legacy databases, Oracle databases often hold highly critical enterprise data like transactions, customer data, contracts, and other valuable data intelligence sources. Confluent's Oracle CDC connector seeks to solve the challenge of integrating with Oracle by efficiently identifying and capturing data added to, updated in, or removed from Oracle relational tables. Compared to Oracle Golden Gate, using Confluent can reduce licensing costs by $2.5 million over 5 years for large-scale use cases. So, a lot going on here. Let me present the technical view of how MongoDB and Confluent can help you with your data modernization, CDC from databases, mainframes, and an array of connectivity to legacy data warehouse and applications. Confluent connects all of your organization systems and applications via a single platform, enabling data to flow freely across and securely across all parts of a global enterprise to power real-time applications. In addition to real-time data movement, Confluent simplifies architecture and eliminates the giant mess of point-to-point interconnections that make legacy architecture slow, expensive, brittle, and insecure. Instead, you get a simple, lightning-fast, resilient, secure data plane with Confluent with infinite topic sizes and/or infinite retention in the cloud. Depending on your existing architectures, there are multiple ways to deploy your solution. You can have completely cloud or completely on-premise deployments, and of course you can have hybrid. In a hybrid scenario, the data is first sent to on-premise Confluent cluster, and then pushed to a cloud cluster using a secure replication mechanism like Confluent Cluster Linking or Replicator. You need an intelligent operational data platform, something like, I don't know, MongoDB Atlas, at the end of that data stream. MongoDB and Confluent give you the freedom to run anywhere, provide you the coverage in any geographic location, help you leverage a multi-cloud strategy, and best of all, help you avoid lock-in from cloud service providers. So again, if this is a too much didn't listen type scenario, Confluent connects all the things, and we can deliver those things to MongoDB. So I wanted to call out a quote. I'm not going to read it to you guys, but I'm going to call out a quote here from one of my favorite customers, AO.com. They have had tremendous success using our cloud platform, Confluent Cloud, that has enhanced their data-driven functions. I've gotten to work with John Vines quite a few times. I'm a big fan of his, but let's take a closer look at that use case. So for anyone who is not familiar with it, I know I wasn't, AO.com is one of the UK's largest electronics retailers with over 6 million customers across the UK and Germany. Think of them like Best Buy, right, but just online only. The customer personalization team at AO.com takes customer engagements to the next level by providing a unified, hyper-personalized experience based on a deep understanding of each customer. Confluent Cloud and event streaming enables them to treat each customer visit as a unique moment by combining real-time digital signals with historical data, giving each customer what they want when they want it. Now, let's dive into the details of our demonstration today. First, we'll extract customer data in real time using our fully managed Oracle DB CDC source premium connector. Next, we'll transform the incoming data using a single message transform to mask sensitive customer data. Then we'll source real-time transaction data for RabbitMQ using our fully managed RabbitMQ source connector. Next, we'll merge those two data sources and build fraud detection using KsqlDB. Finally, we'll load the fraud detection results into MongoDB Atlas using one of our fully managed sync connectors. And away we go. Let's start by taking a look at the customer data we have in Oracle DB. In the customer table, we'll have customer ID, customer first and last name, date of birth, average credit spend, and some other customer information. We're going to be using the customer ID field later to match our customer data to their credit card transactions data. Navigate to the connectors page under the data integration menu and search for Oracle CDC Source Premium Connector. This fully managed connector allows you to reliably and cost-effectively implement continuous real-time syncs by offloading data from Oracle DB to Kafka without any operational overhead. That's awesome. To configure the connector, we'll supply all the necessary information needed to access our Oracle DB. Near the bottom of the connector configurations page, you'll find the single message transforms related field, which we'll use to mask sensitive customer data. We'll enter a name for the SMT, DOB_mask. Then click Add Transforms to reveal additional fields. Select the transformation type as mask field $value, then select the field DOB on which the masking will be applied. The DOB field will be masked with the value provided in the replacement field, which we'll replace with XXXX-XX-XX. You can use any string value as a replacement here. Let's launch the connector and check to make sure it's up and running. Now, let's check the contents of this oracle.dbusers.customers topic to validate the records coming from Oracle. Here we can see that our SMT is working as expected with the customer's date of birth redacted and replaced with the string pattern of our choice. With our pre-built and fully managed Oracle CDC Premium Connector, you've now performed a highly complex integration with just a few clicks that would have otherwise taken on an average of 12 to 24 engineering months to replicate in-house, and even more time and resources to manage. Now, we'll switch gears and examine our second data source, which is credit card transaction data in RabbitMQ. Let's take a look at the transactions table. It contains fields like user ID, transaction timestamp, transaction ID, charged amount, and other relevant information. We'll need to get this data into Confluent Cloud as well, which we'll do using the fully managed RabbitMQ source connector. Let's create another Kafka topic called RabbitMQ_transactions for the transactions data. We'll search for and start configuring this connector. Similar to the fully managed Oracle CDC connector we used earlier, this fully managed RabbitMQ source connector also abstracts away all of the operational and management burdens associated with self-managing connectors. Let's tell the connector all about our RabbitMQ queue and connection details. Now that our connector is up and running, let's quickly step into the transactions topic and check out the events that are in there. Since the connector is running, it will automatically bring the updated data from Oracle database to Confluent Cloud after the initial setup. For example, if one of our customers recently increased their spending, we want to update average credit spend to make sure we aren't flagging transactions based on previous data. Let's go ahead and update Rika Blaisdell's average credit spend by 5,000. Now let's verify the new amount is added to Oracle DB users.customers topic. Voila, there you have it. Once all of our data is in Confluent Cloud, it's time to merge them and build our fraud detection logic using KsqlDB, which enables real-time stream processing with SQL-like commands. Let's start by creating a new KsqlDB application and writing some queries. First, we'll create a stream of customer data from the Oracle topic and a stream of transactions data from the RabbitMQ topic. Then we'll create a table using the customer data stream and the common field customer ID to join with the transactions data stream. Next, we'll begin to write the logic for detecting fraudulent transactions. We'll do this by aggregating the streams of transactions for each customer ID using a 2-hour tumbling window and filter for customers whose spend in a 2-hour period is higher than their average spend. Let's create a new table called possible stolen card, sum their spend over the defined window, and compare that to their average spend. Now that we have our customer list with possible fraudulent transactions, let's load this into MongoDB for documentation and further analysis. We'll search for the MongoDB Atlas Sync connector in Confluent Cloud, and similar to the source connectors, it's a quick and simple process to launch a fully managed sync connector to send data to your target system. Let's tell the connector all about our Mongo database, filling out the connection details, key, schema, and launch the connector. With the connector fully provisioned, let's go over to MongoDB and see what has happened. We could see that all the data is here. We won't go through all the details, but it's sufficient to say that we've taken our data from our legacy database, joined it with other valuable data, and processed it with KsqlDB for real-time fraud detection. and log the results in a modern cloud database, MongoDB Atlas. So one thing I really wanted to call out there is that we took a relational, traditional database like Oracle, right? We took RabbitMQ data and we were able to format it in such a way that we can land it in Mongo, right? So that is something we could do. We could just have gone straight from Oracle to Mongo. We could have gone from Postgres to Mongo. The point is, we could take any of your data and get it from any data source into any data destination. And something that we covered in there that we didn't talk about, but I'd like to just spend a minute on it, was KsqlDB. So we talked about, producer-consumer model of Kafka. We talked about the Connect API, but there's another API called Streams. Now, Streams API allows you to build streaming applications. So like what we did here, where you can combine data, you can merge it, you can transform it, but you have to write it in either Java or Scala. I can't write Java or Scala, right? But I can write KsqlDB. So what we built at Confluent is an abstraction layer on top of Streams that allows you to take that same type of functionality, but do it using select statements and create statements. Because what we wanted to do is make this very accessible to all of our database administrators, right? We want to get them on board with the idea of streaming and building streaming applications. So with that, does anyone have any questions?
Yeah, I'll just give you a microphone because we're recording so we can all pick it up.
Yeah.
Perfect.
Do you really need to store the data eventually in MongoDB? Can you keep the infinite amount of data in KSQL or?
That's a wonderful question. Just in case anyone hear it, the question was, does the data have to land in Mongo or can we keep it in Kafka? Well, absolutely. So in both our self-managed product, we have something called tiered storage, which can allow you to write things to disk, but also send things to object store for long-term storage. In the cloud, we have infinite. So we can set up, you could set retention or topic size to infinite, and as long as our cloud provider doesn't run out of disks, you will never run out of space. So we actually, what you tapped into is a very common pattern. So in this case, we had a narrative around the data analytics team using Mongo for fraud detection, right? But that same data could be used by 4 other business units accessing it directly from Kafka. So wonderful question.
Hey, when you say it's able to do CDC, does that mean that it's just kind of creating a log of all the CRUD that's happening, or is it actually kind of like reflecting the updates in the Mongo database?
Very good question. So it really depends on which connector we're talking about, which CDC connector. So let's pick on Oracle for a minute. The way our Oracle CDC connector works is it uses log miner. So you have to set up the redo log on your Oracle database. And then what our connector does is it creates a session in the log miner and it watches it. And it's picking up all those updates, right? So it's just replaying them into the Kafka topic. And if for some reason connectivity was severed, it knows the last place it was in log miner, reconnects to it, and just replays wherever it left off. Great question. So we have another one right here. Look at that.
Yeah, I know it's easy to change the data from the relational database to MongoDB, but from MongoDB to relational database, what kind of changes or how do you do the CDC?
That's a great question. So we featured our Mongo sync connector, right? But we also have a Mongo source connector, which means we can go into those collections and we can pull that data in. Now, we're probably going to at least initially pull it in as JSON because that's how MongoDB works, right? But once it's in the Kafka, we can reserialize it into any format we want. So we can keep it in JSON. We can reconvert it to Avro or protobuf. At that point, you're just dealing with bound data, okay? To Kafka, it knows there's a field and a result. That's it. It doesn't know that it came from a relational database or it came from Mongo, right? It's completely kind of ignorant to that fact. So you would then reconfigure the data you want, meaning, do I want to reorder the columns? Do I want to change column types or sizes or formats? And I could do that through KsqlDB, and then it would create an output topic. We can then take that output topic and sync it to your destination of choice. So a lot of customers are going the other direction to Mongo, but it's certainly possible to go the other way. And Mongo may be your source of truth, but you maybe want to take a subset of that data and put it somewhere else. Confluent can help you with that as well.
Thanks.
Wow, this corner is hot.
I hope I'm not missing any, but yeah, we have some time.
We do have time, and I get all day.
For data syncing between 2 MongoDB databases, let's say, what do you think is the best way keeping Confluent in between, or maybe using the native MongoDB service like data replication? Is that the best way, or Confluent? I want to keep the 2 databases
databases in sync in real-time manner?
Well, Confluent could definitely do that for you, right? So we're talking about syncing to Mongo databases. And I think it comes down to if you're only trying to keep the databases in sync, and that's the only thing you're trying to do, I would say use Mongo native replication. However, let's say maybe you have an expanded use case. You want to keep them in sync, but maybe you also want to do some data transformation. Maybe in downstream you want to have some summary data, or you want to enrich it with some other data source. I would say in that scenario, Confluent could really help you because you could source your initial source database, incorporate another data source like we did in our demonstration today, and enhance it or massage it or remove a field or whatever makes sense, and then sync it downstream. So if you're going to do some transformations, I think that's a good use case. Another good use case is offloading. So let's say we had MongoDB in one part of the world, and we had another Mongo in the other part of the world, right? And then in between are all of our data services because we're a global company, right? And we don't necessarily want to go to Mongo in the source or the destination cluster for that data because we want it at lower latency. If we have Kafka running, say, in one of your regional offices, we could be sourcing that data. Maybe we're not using it necessarily to keep them in sync, but let's pretend we are. You don't have to grab that data from Mongo anymore. You can have a consumer, you can have microservices that are consuming those records, and they don't have to go to Mongo. So let's say you had some security posturing. We don't want anything except for Confluent to connect directly to Mongo outside of this data center. There's a story there as well. So it's very flexible, but if you're only doing replication, I would say use Mongo. If you want to offload or add some enhancements or massaging or manipulation, Confluent's a good choice.
So one follow-up.
Sure.
On that. So using chain stream along with Confluent and then data syncing, like that's how yours is.
Yes.
Okay. Yeah. All right. Thank you.
Thank you.
2 seconds, I will get to everybody. I hope we have some time.
Yeah.
How you doing? Great talk.
Thank you.
Could you speak to some differences between the cloud-provided Kafka clusters and Confluent?
Yes, in fact, I talk about MSK every single day of my life. So I'll pick on MSK for a minute. So if your question is around other managed Kafka sources. Picking on MSK for a second, I view MSK as a managed install of Kafka, right? Like what you're getting from it isn't dramatically different than if you did the install yourself. So that's okay in the right use cases, but I think the big value prop is Kafka at scale, right? When you're dealing with scaling, MSK, for example, is going to require you to figure out what the scale of your cluster is, right? There's no magic button. For us, we want to know your throughput. How much data in, how much data out, how much you want to store. That's how people really measure Kafka. We're not going to ask you to figure out what family of brokers you want to use, what size of brokers, how many, and on top of that, the size of their disks. Because MSK will absolutely let you pick the highest scale instance with basically no disk size, which will not perform. That's just not how Kafka works. And they don't have the tooling built into it to facilitate that. What they have is a platform that can turn up open source software, right? Whether it's Elasticsearch or I guess it's open source now, or it's Redis or Memcache. They're all kind of using the same fundamental platform underneath, right? So that's one just from an operational standpoint, and then the intellectual property on top of it, right? So the connectors, KsqlDB, and something that's really important is keeping your cluster running smoothly. So something that happens in Kafka is you have topics, and the way you enhance performance is you partition them across many brokers, and you scale them out horizontally. However, not all partitions are created equally. And what often happens is one will get hot. And now the performance of your entire cluster suffers because most of the data or half your data is going to one partition when you have 10 partitions. Well, if you want to fix that, you have to run partition reassignment tools, open source tooling against your MSK cluster in order to get it performant. All of that we're doing under the hood completely for you, right? So the comparison I think of, and I think this is a pretty apt one, is you think of like, for all the Mongo folks, if you ever use DocumentDB versus Mongo Atlas, it's a much different experience. If you've ever used CloudWatch versus Datadog, it's a much different experience. So all in all, maybe slightly more expensive at sticker price, but the value you get in terms of low operational overhead and enhanced development times, I think far outweighs that.
Sorry. Well, what about the connectors for Confluent? Will they work on the cloud provider?
So we're the only ones that have the connectors. Okay. MSK does have Connect. But if you look at their FAQs, they actually tell you to come to Confluent for the connectors themselves, and we will not sell them to you that way. So I don't know what they're thinking.
Thank you.
Sure, I think there was one behind me here.
So 2 questions, one technical, one cultural.
Great.
So technical one is, what are the keys for me for Confluent Cloud is the abstraction that I don't have to worry about dealing with the clusters itself and the machines that are underneath it.
Right.
But in a hybrid situation, you mentioned that I need a cluster on-prem.
Right.
Who manages that cluster?
Okay, it's a great question. So we have tooling that makes managing our self-managed product easier. So we have Ansible playbooks for anyone who's running Ansible. We have an operator for Kubernetes. So if you're running OpenShift, Tanzu, or out-of-box K8s, we can, and I can attest to this because I do it all the time, we can get Confluent Platform up and running in under 5 minutes. So the answer is you. Now, that said, it really depends on your use case. You don't necessarily have to run full-blown Confluent Platform on-prem. Let's say, for example, you had some advanced networking use case and you said, hey, I don't want the cloud reaching out across my direct connect and pulling data. I would rather have that source initiated. What you could do is just install Kafka Connect locally, run a connector there, but use Confluent Cloud as its backend.
That would be the self-managed connector.
Yes, it would be a self-managed connector, but we're still going to make that easier for you because let's say you have Kubernetes already up and running, you can use C4K to just deploy that component, and within one YAML file, you can be up and running. Now you have that connector running there on-prem, you can whitelist that traffic to hit Confluent Cloud, and now you have a really beautiful setup.
So then thanks for that.
Like the cultural question.
Yes, another cultural question, right? So how do you deal with the leadership that says, I don't need streaming data? But on the flip side of the coin, you're running batch scenarios that are moving millions, if not tens of millions of records across the network, and it takes hours. How do you get them to understand that Kafka could also be used as a queuing, as a staging, so you're pushing that data all day long, and then you're running micro batches. How do you get them to see that picture? Because I can't do it.
Well, so that's a challenge, right? I got to know your leadership to really know better. But one of the aspects I look at is what are my competitors doing, right? Is there a competitor in my space who's newer, right, and are doing things faster? The one I always like to go through is Netflix, right? So you may not realize it, but every time you're going through a Netflix menu, you're going through Kafka, right? And that type of front-end experience is, I think, what all of our customers expect. Right? Especially as we become the old folks, right? The new generation that's coming in, that's going to be our primary customer in 10 years, they've never been bored in a day in their life. They've had cell phones, they've had tablets, they've had high-speed internet. I remember dialing up, right? They've always had that. So I think if you're not aiming to get your results in minutes, or I would even challenge you to say seconds and milliseconds, you're going to be falling behind. But I think that's one way to do it. The other, from a technological, cultural standpoint, I mean, that's a bread and butter use case for us. You can have things streaming in the Kafka. You can have consumers consuming it in real time, but also you have the freedom to go micro batch every 5 minutes or whatever makes sense for you. So to me, it gives you the freedom to go batch, but prepares you when you're ready to go real time.
Thank you.
There was one over here.
I just want to thank all of you. I know I'm between you and lunch, and I know I'm feeding your minds, but this is very impressive. I thank you all.
Thanks for the talk. We have a use case where we are looking for a multi-region consistent environment.
Okay.
Obviously, like one of the solutions that we have in our mind is to straight up hook up to Mongo chain streams and then do our processing off of it. But is there something that Confluent Cloud is planning to offer? Because my understanding is that Kafka right now is not multi-region consistent and it's just single region.
Wonderful question. Well, in Confluent Cloud, we are in every cloud provider, in every existing region, and we are always turning up new regions. With that said, there's still another piece to it. It's the technology that keeps those things in sync. Now, if you're talking about RPO 0, you don't want to use Confluent Cloud right now. You'd want to use something called a stretch cluster or a multi-region cluster, where parts of the cluster exist in different parts in different regions, and you just have some latency requirements. So we have professional services that can help you do that. We would do that with Confluent Platform. Now, if you don't have RPO 0, and you can live with some milliseconds of latency between the two clusters, the easiest way to do it would be Confluent Cloud in 2 different regions using our newest and latest and greatest replication technology called cluster linking. At that point, you're only going to be lagging by physics. So if you're 70 milliseconds away from the 2 clusters, you're only going to be 70 milliseconds behind, from your source and your destination cluster. So it really depends on your use case.
Excellent. Is there any last question for Joseph? We're good. Joseph, that was superb. Thank you so much.
Thanks, everyone. Have a great MongoDB world.